So requirements are key to a successful project. This is an important thing for student teams to learn as to why you do requirements and what requirements are and how you correctly formulate them. So this is from a NASA document, a NASA presentation on project management, and we do have this on the website, so you can go through this. So requirements really are important to project success because it enables you to identify, first of all, what is needed for your project, and it allows you to eliminate things which would just waste your time. So, for example, in our example of measuring temperature as a function of altitude. So you could, you could say, oh, okay, well, we can take data at 100 times a second with the temperature, and that's great. But do you really need to do that? Right. So if you do 100 times a second for 3 hours, you get a boatload of data, which then complicates your life in terms of transferring the data to your ground station, analyzing your data. And is it needed? Well, you would need to identify with a requirement as to what is necessary. So if you say that your requirement on your temperature is that you need to distinguish the temperature profile to within plus or minus a half a degree or a degree or something like that, then that automatically sets you in how often you need to sample that data. So even though you could sample it 100 times a second, you don't need to. And thus you don't have to waste your time doing things, either storing that amount of data or trying to figure out how to analyze it. So requirements are very important. You need to determine how to actually, some of these requirements are either derived from objectives or from other requirements, or they are flown down, what are called flow down requirements from systems that you don't have control over. For example, your payload is defined by ASIS management to weigh no more than 500 grams. So there's a technical requirement for you. Payload shall weigh less than 500 grams. Okay, that would be a flow down type requirement. All right. And as soon as you start, so as we talked about in the last lecture, as soon as you start working on your system design, you're going to see new interfaces and new requirements derived from that. Requirements, so problems in defining the requirements or communicating them, that is the single biggest cause of project problems. These requirements drive almost everything in a project: your cost, your design, your schedule, your procedures, what skills are needed, etc. So you need to be very careful about how you run these things. The other thing here, that this last bullet is also important. It is amazing how many teams begin to solve a problem before there's agreement on what the problem is. Right? I've seen that countless numbers of times. You have to be careful and you have to watch out for that. All right. Many criticisms that I will see on a PDR document, you will see me write on there, this is a implementation, not a requirement. Okay, when you're people who are listing things. So be careful about that. The requirement is a statement that provides a contract. It gives you understanding across all team members about what thing is needed or wanted, or some characteristic of something that is wanted or needed. Those are important characteristics, why you do and what is a requirement. Here's a nice plot. So as your project goes on, as you go from your initial stages now through your detailed design, through production and implementation and flight as the project progresses, your costs or your investment, could easily say investment here, increases. You're going to continue to spend your time, and that is in fact the money that you're spending. You are investing time in this LACES payload. So your cost, your investment in that project goes up, right? So your commitment follows this kind of a curve. So once you get to something like, so initially when you're up here, you have relatively low cost and you haven't really committed a lot yet. You're going to be spending something like, whatever it is, 10 hours, 15 hours a week for the rest of the semester up here. So right in this early stages, you haven't invested a lot yet, right? But as you continue to go through your detailed design, you're going to come up here to your pre-PDR and then your PDR, where you're going to have some very good idea about what your payload is, and then your CDR. You're going to have committed a lot of your time, all right, in investing in this thing before you actually get to the end of your payload. So any mistake that you make up here has a lot of implications down at the end of your project, okay? The requirements enable you to understand, and to validate your commitment costs before they even occur. So that's another reason why we do these kinds of things. So requirements change, all right, and so there's a cost for fixing a problem with a requirement as you go forward with this thing. So this is a log scale, all right? So in your early stages, when you're working on your project right now, fixing a requirement doesn't cost you a lot. But if you're back here with a payload almost ready to fly, and all of a sudden, oh, we forgot to include the battery requirement, right? You may or may not have an issue, right? So early stages is when you really want to do it. So where do these requirements come from? Well, I've already said that a bunch of your requirements come from your goals and objectives. Well, LACES management, Aaron, myself, Doug, they're going to lay requirements on you. You already know some of them, all right? What's the distance between the two strings that pass through your payload for you to attach to the LACES flight string? 17 centimeters. That's a requirement imposed on you by LACES management. And there's probably other ones as well. You probably have some idea about what your operations are going to be. Those are going to set some requirements, right? There might be some analysis that you do, which would be in there. And then there's, functions that your system must do or perform during the mission. You're going to have to collect data. That data is going to be analyzed. So there's requirements that would be derived onto how you're going to analyze the data after the flight. So there's a lot of different sources where these things come. There are particular items that can be used. A lot of government agencies can define how you write requirements in different fashions. If you get really excited and interested, you can look up some of these NASA, different ways of defining the requirements in here. Your operational considerations with your interfaces, and then your environment, whatever environmental type interfaces would require. It's important that you be deliberative about how you identify and define your requirements. These requirements sort of define the scope of what you need to solve, and they could make a project go from doable to undoable if you don't spend that time. You should be able to trace your requirements. We talked about a traceability matrix. You should be able to follow a requirement from a particular item of your objectives and your goal. You should be able to do that. You need to understand how to write a requirement, because a requirement has got to be verifiable, and it also has to be understood as well. So we'll go over how you write requirements. All right. There's a couple ways that you can define requirements, as I mentioned before: flow down, allocation, and derivation. So a flow down is a direct transfer, since a subsystem provides a capability. So we saw some of those in that example that I gave on the system design for that power bus being 28 volts. So that set a requirement on what the battery is supposed to provide. That battery is required to provide 28 volts, right? So that's things that can be flown down. There is a allocation. So things like mass. So you know that the payload, your payload has to be less than 500 grams. Well, then you allocate so much for your battery system and your control system and your sensor subsystem and your mechanical system, and you have contingencies on those as well. So that would be allocation of those kinds of requirements. Then then a requirement can be derived, right, upon a specific objective. So, for example, here they say, so a car may have a 110 kilometer per hour performance requirement that is used to establish a requirement for a maximum mass and a minimum horsepower. Okay, so the car has the newly developed car shall have a maximum speed of 100 kilometers per hour, and then from that 100 kilometers per hour, there would be a derived on the maximum mass. So it can't be the weight of the moon. It'd be kind of hard to accelerate that one with a reasonable power system, and also what would be the horsepower of the engine, right? Or orbital vehicles performance. So those kinds of things would be derived from stuff. And then here's your traceability matrix as I discussed. So your traceability would go, many times let me see what's on this next page. Okay, so the traceability many times would go across a page like this. So you start off with your principal goal or objectives, and then you go down to level 1 with your level 1 requirements, and then some of these requirements would have additional requirements. So that would be a level 2, 2.1, 2.2, 2.3, and some of these might have a third level requirement. So that would be part of what your hierarchy of your requirements were, and then to the right side, which they don't show here, is how these requirements then correspond to what subsystem is and what gets actually implemented on this. So types of requirements, right? Functional requirements. What an item must do. So the system shall provide communications between the ground and the spacecraft. Performance. Requirements which define quantity, how well an item must accomplish a particular function. provide communications over what range, at what data rate, how often. Constraints, requirements that capture operational, environmental, safety, or regulatory constraints. So X-band frequencies, temperature, base plate temperature, et cetera, et cetera. And then verification. Requirements capture how confidence will be established that the system will perform in its intended environment. Okay? So these are things. When you are putting together your requirements for your pre-PDR, you need to look at each one of these different types, because I guarantee you, you are going to have multiple requirements in each of these categories. All right, so here's a NASA example of some crew exploration vehicle requirements and distributions. So a system performance requirement would then derive to a flight segment performance document. So you see that these are derived back in through here. Then there's a flight vehicle contract end item, which also specified, which then gets derived into here. So flight vehicle shall provide 4 omnidirections, all right? And those, that omnidirectional antenna then derives into another lower level, which specifies exactly what the equipment specified should be on which drawing and how that system should be wired, et cetera. So you can see how these requirements define further requirements as you go through your document. Again, here's sort of a diagram of this, where you start off with system, which has a certain set of requirements that goes to children's subsystems, which have their own set of requirements, which go to other kinds of subsystems. So it's I'm iterating this, I'm reiterating this again, that the system design and the requirements go hand in hand. They feed off each other, right, as you go through these things. And your system design also identifies your interface, and there's obviously going to be requirements on those interfaces. We've been talking about some of this stuff, right, as we go. Key interface documents, we did the ICD here. You know, some of these other ones you don't really need to worry about in terms of separate documents, but the content, so defining that interface and what the requirement is on the interface, and then how you're going to communicate those interfaces is all important. All right, so here's James Webb. So James Webb just got to L2 the other day, fully deployed. And so they had, I don't know, multiple decades of doing this project and following the requirements. And so it worked. So all of this stuff they managed to get it going. So the summary on this thing, all right, is as so. Requirements define the problem to be solved, right? And it helps you measure success and constrain the issue. These requirements, you know, problems with requirements can totally screw your project. Okay, so you need to spend time to figure out what these are. As you progress through your project, it becomes more costly in terms of your time invested as you go later in the project before a problem is discovered. These requirements are usually distributed through or identified through processes such as slowdown, allocation, or derivation. A traceability matrix or requirements traceability is very useful to try to assess the completeness of your requirements and how and whether requirements are actually necessary. And then finally, as you decompose your system, design is smaller, you're going to create interfaces, and those are going to have to be defined and managed as well. Okay.